Hello, Tom Wiersma here, one of your co-hosts of IPM's Packaging Pundits podcast. We're bringing to you experts from throughout the industry that will share points of view and insights as to how to improve your packaging system. It could be an aging system, it could be a greenfield system, but we'll bring all those experts in and they'll provide insights as to how to optimize your operation. Looking forward to speaking with you. So I've heard it said that palletizing often is a bottleneck in a food and beverage operation, and that operators are struggling with which palletizing solution might be best for them. What are some of your thoughts around that issue?
Yeah, I think palletizing there's a lot of options that are out there for how you would actually palletize something. So conventional palletizing, robotic palletizing, one of the new buzzwords is the cobotic palletizing of how do you pick the right technology to actually apply. And I think some of the challenges that we see is we might come into a situation where it's, hey, we want to use this technology to palletize. And that's not really the right way to approach palletizing.
Because when you say that we want to, what do you mean? The customer comes to us?
Yeah,
Okay,
yeah. So the end user of, hey, I like robots. They're the new cool thing. So I want to put a robot at the end of the line. Well, you can, but is that really the most efficient way that you should be palletizing that sort of product? So there's a lot of things you need to think about when it's what are you palletizing and how can you actually handle that and manipulate that product to be able to put it onto a pallet. So is it something that's, a very, tall, thin product? Is it something that has just film wrap over it where there's some inconsistencies on the product and how you're going to pick it or how you're going to, manipulate that product? Are there rates? What sort of rates are you trying to accomplish? That maybe there's other technology out there that would more efficiently and effectively position that product and do it in a smaller footprint, smaller price point. You really want to look at it from a system standpoint, not a technology. I want to have this as my palletizing.
Yeah. So I can see that, but so as a customer addresses this issue and begins to accumulate input to help make a decision, is rate and throughput going to be maybe his most essential criteria?
That's where everybody needs to start. I mean, you want to maintain, and there should be some level of pull away built in by the time you get to the palletizer. So you want to have everything being able to pull away as you kind of design your line, like we talked about in one of the previous episodes. Yeah. We want to be able to pull down any accumulation and have your palletizer not be your bottleneck. So you want to make sure you've got enough buffer in there as you're designing around a rate. Put in an additional 20%, 30% of pull away speed from what your line design rate would be from your palletizer. And then it's based off from that case rate or whatever tray or product you're handling, how fast is that feeding into the palletizer? So typically when you're building a pattern, you're not just continually flowing product through. There's technology out there for higher speed where you do need to keep that product moving. So how you manipulate that and how you need to sequence it and then build your layer out to be able to pick and palletize a layer or conventionally orient it and then drop that onto a pallet. So rate is a big driver and making sure that you've got everything set up appropriately. And that's where you start getting in, honestly, some of the more conventional mechanical methodology actually can go a little bit higher speed than what robotic palletizing can, just because of how you're manipulating it and being able to keep it moving.
Is there also a weight issue that impacts specification?
That really comes into play from a robot standpoint. So you really need to think about payload and what you're picking and placing. The main robot manufacturers have different levels of payload that they offer. So it might be a smaller robot to only do 180 kilograms or something like 315 or 400 kilogram payload robots. So you got to think about the payload and utilization. So that robot's going to pick and it's going to place. And you got to think about it in terms of maintainability. You don't want that robot running at 100% all the time. You got to build in, because then you're going to be maintaining it more. You're going to be wearing down your servos quicker. You want to be able to run it at an appropriate rate and speed. And also, if you've got a heavy case and you're winging that thing around and all of a sudden you've got a risk of dropping a case or something happening and now there's a safety issue. So Safety is a huge thing that you're talking about with this too. Of as safety continues to build, and we need to be able to build safe environments, workforce, keep our employees safe. Safety is critical when you're talking palletizing systems, especially robotic systems, and how you need to interact with those systems.
Safety is the key issue for either specification.
Yes.
Yeah.
And it's a key decision point for a lot of customers. There's a big reason to go to a robot solution from a safety standpoint, because you can guard that and lock everything out.
True.
There's some safety concerns when you're talking mechanical building of a pallet, a hoist that has, a pallet that you're moving up and down instead of manipulating the cases and putting it on a pallet. Like, there's a lot of weight on a full pallet that comes in, and then if that falls over and there's somebody walking by, that's a huge problem.
Are there any limits in terms of pallet build height? Does one or the other have a height imperative?
More customization maybe would be what you'd have. Conventional palletizing, there's standards around. Like, if you need a taller one, then you can get into a more custom built machine.
Yeah.
Robots are completely hinged on the reach of what the robot can pick and where you can place it. And then if you're doing a robot with multi-lines, where you've got multiple lines coming in and you've got one robot arm that's picking and placing, you need to be able to move around and maybe go over top of a layer or a pallet load that's there. So you need to be able to have enough built into the design on the front end to be able to handle that.
So to that issue of multiple lines, can both conventional and robotic palletizing handle multiple lines simultaneously?
Yeah. It's a different approach. With a conventional palletizer, you've got one input typically, where you've got one product lane coming in. So you basically accumulate with conveyor upstream, and then release one pallet's worth of product at a time. And so you're basically indexing in one pallet of product A, and then that gets done, you release the next product for product B. And so you're doing a multi-lane, but it's all done with conveyance. So that's a lot of cost, a lot of infrastructure, a lot of maintenance that you're going to need to do down the road on your conveyance. But that's definitely one way to handle it. Rates on a robot would drive what you can and can't do from a correlation standpoint. That you're limited by how many movements you can get out of that robot arm.
Got it.
And so driving that forward of, okay, if you've got slower speeds that you can combine multiple lanes, now you've got a more cost-effective, maybe a smaller footprint to be able to do two palletizing systems with a robot that you would have to put two conventional palletizers right next to each other.
Okay.